Hi, my name is John McMaine. I'm an assistant professor and extension water management engineer. Today I'm going to talk about one of my favorite topics, water management and water quality. So out here at the Southeast Research Farm in Beersford, South Dakota, we are doing a winter rye cover crop trial. And the purpose of this is to look at the impacts of winter rye on water quality. So studies across the Midwest, one in particular in Illinois, has demonstrated that winter rye can reduce concentrations of nitrate in tile drainage by around 40%. So, does that translate to the same results in South Dakota? So far, we've seen little to no difference in concentration coming out of the tile. And so the reason we think this is as many of you probably know, cover crops are tougher to establish in colder climates like South Dakota than they are in warmer climates like Illinois and Iowa. The challenge here that we're facing is the last 2 years that we've done this trial, we've had very wet conditions, harvest has been late, cover crops has gone in late towards the end of October, and so it's been hard for the cover crop to get established, and then we've had challenges with growth in the spring. So we don't get the amount of biomass that we would hope to really see that impact. We will continue to do this study because we believe that there is an impact, but a lot of it comes down to management. The other two things I want to talk about related to cover crops and water quality is the availability of nutrients. So if you think about a cover crop, how is it impacting water quality? Well, it's taking those nutrients up through its roots into the biomass. But if you think about the amount of biomass that's produced, you have to get a lot of biomass to really see differences in the soil nitrate concentration, which then translates to water quality. The other piece is when the nutrients are available for the following crop. So as with any nutrient, you have issues with timing. It's hard to get cover crops established when you have a very late harvest. You don't have a large window to get the cover crops in and then get biomass production. You need biomass production for the cover crop to effectively pull nitrate and soluble nutrients out of the soil profile into the biomass. So that's challenge number one. Challenge number two is nutrient availability. So with any nutrients, it has to be bioavailable for the crop when the crop needs it for it to actually be taken up into the crop. Cover crops hold on to those nutrients, but they may not break down or be bioavailable when the following cash crop needs it. So those are the two challenges we're looking at. But cover crops have a multitude of benefits, been demonstrated they have water quality benefits in other places, and we think that they will have water quality benefits in South Dakota, but we need to continue looking at management and how we can best effectively manage cover crops to have water quality benefits. The other practice I would like to talk about today is something called controlled drainage. Now, controlled drainage is a way to hold water in the soil profile when we don't need drainage. So if we think about nitrate loss or nutrient loading, it takes two things into consideration. One is concentration, or the amount of nutrients in the water. So this is given in milligrams per liter or parts per million. The other side of the equation is the flow, or the amount of water that's actually leaving the system. So with controlled drainage, we can use a control structure that has boards that essentially form a dam in the soil or in the control structure, which backs the water up into the soil profile when we don't need drainage. So we did a 3-year controlled drainage study here in the plots that we're in, and we saw reductions in volume leaving, and so because of that we saw nitrate load reductions. There's also significant studies going on currently across an 8-state region, the Transforming Drainage Project, and what we've seen with those across the range of climates is nitrate load reductions, not concentration reductions, but nitrate load reductions in the order of 30 to 50%. Controlled drainage also has the ability to improve resilience for the crop. If you think about it, after you get in there for spring field operations, put some boards in there, hold some water in the soil profile, any timely rains you get will now be held. Now you want to be careful and manage this so you don't back up the water too much because you need the benefits of drainage. But Controlled drainage gives the ability to manage water in a way that improves water quality and can potentially provide crop production benefits.